Hello, ladies, gentlemen, and gentle thems. We are talking about increasing, decreasing, and constant intervals today. What that means is we're going to be looking at where does the graph go up, where does the graph go down, and where is the graph flat. So those are the three things we want to be able to do today, and we want to be able to tell other people where they're at using interval notation. All right, so let's get going. Let's start with our vocabulary. The first thing we need to know is what do we mean by increasing, decreasing, and constant? And those three words, we're just talking about the slope of the graph. If it's increasing, what that means is that our slope is greater than 0, meaning our graph is going to go up to the right. Okay. Decreasing is just the opposite. It means our slope is less than 0, or negative slope. And that means our graph is going to be going that way. It's going to be going down to the right. Okay. And then constant just means exactly what it sounds like. It's constant. It's not going to change. It's going to stay at the same height the whole time. Okay. All right, so those are the three things we're talking about. Remember, we are looking at the slope of our graphs. Before we get into looking at any graphs, I don't want to overwhelm you, so we're going to talk about interval notation. And this is something you've probably seen before, but let's go over it really quickly just to make sure we understand everything. So this is just a notation we can use. There's two different ways we're going to indicate some things. We're going to use parentheses and brackets. And the parentheses mean that we are not including the ends. So one way I could write an interval is parenthesis 2 to 4. What this interval would mean would be that it starts at 2 and it goes to 4 and it covers everything in between those. But because these are parentheses, we are not including the ends. They'll have open circles. There's a hole on both ends. So this includes 3.99999, so on until you're annoyed. It means 2.0000 and then a 1 at the end, but not 2 and not 4. It doesn't include the end points. Okay. Brackets just mean the exact opposite of that. It does include the points. The ends are included. So if we had 2 to 4 with brackets, it's going to look pretty similar. It's still going to include everything in the middle, but it includes the point on the end. Okay. It is possible to have a combination of those. You are allowed to have something like 2 to 4, where the 2 has a parenthesis and the 4 has a bracket. And then that would just look like this, where we have an open circle on the 2. We're not including the 2, and we are including the 4. Okay, so that's interval notation. Let's look at a couple of examples in words and just make sure we can write these in interval notation. So our first one says from -2 to 8, including both ends. So including means we're going to use brackets. Always put the smaller number on the left side. And when I say smaller, I mean more negative. So this one, because we're including, we'll use brackets. Make sure we put our negative number first. So bracket, -2 to 8, bracket. Okay. From 0 to 100, not including 0. So it doesn't say omit the 100. We're going to include that. So the 100 will get a bracket. But to exclude or not include the 0 will get a parenthesis. So the way we would write this is parenthesis 0, comma 100, bracket. All right. And then the last one, from -5 to 5 inclusive. The word inclusive here means include both ends. So that means both of these will get a bracket. So this could be bracket, -5 to 5, bracket. Okay, so there's 3 examples of how you would change words into interval notation with some fancy vocabulary. You'll impress your English teachers. Inclusive. The opposite of this is, of course, exclusive. All right. So now that we have some examples of interval notation and kind of how it works, we're going to go ahead and look at some graphs. All right, so here's our first graphing example, and we're going to do our best to say where does the graph increase, where does it decrease, and where is it constant. All right, so the first thing we're going to do is we're going to come over here and look at our graph. When we say decreasing, we mean negative slope. So our slope is less than 0, it's negative. The way you check for that is you draw a tangent line. Okay. And a tangent line just means it barely grazes the line. So let's look right here at just this section of graph, and we want to know, is it increasing or decreasing right here? So we're going to draw a straight line that just barely touches the graph, like that. So it kind of touches right there. This straight line has a negative slope because it's going down as we move to the right. So this section here would be decreasing, and we want to know, where does it stop? So our graph is going down, 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 down. Right here, we get to the bottom, and there's a valley there. The mathy word for valley is minimum. If you hit a minimum, you stop going down, and you turn around and start climbing back up this other hill. Then you'll get to a max, or a maximum. And this is where you stop going up. We'll do up in green. And start coming back down. Okay. So we can see here, this red section is decreasing. This green section is increasing. And this red section is decreasing. Okay, so now we need to write these in interval notation. I'm going to go ahead and clean this up a little bit so it's easier for us to read. Whoops, that's not what I meant to do. There we go. Okay. All right, so let's just look at the decreasing sections. We have here, and we have here. So these are decreasing. We want to know, where is this? So when we are telling someone an interval for increasing or decreasing, we are giving x values. Okay, let me say that again. We want to know where on the x-axis this is happening. So if we come look at this graph, on this end we have an arrow, and we'll worry about that in a second. But we're going down, 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 down until we get right here. This spot lines up with -1 on our x-axis. So that's where it's going to end at. So we're going to go to decreasing. It stops going down at -1. We'll talk about the parenthesis in a second. Now, where did this part start? Because there is an arrow here, that means this graph keeps going forever and forever. And this whole time, it's decreasing. The graph is going down. So this graph started at -infinity. It went left forever, and the number for forever is infinity. So we would say the decreasing section started at -infinity. Infinities always get a parenthesis because you can't include infinity. This is like when you were arguing with your little brother when you were like 3, and you said, "Oh yeah, well, I'm smarter than you, infinity plus 1." And then your brother would say, "You can't do infinity plus 1. Infinity's already the biggest." Right? Infinity actually isn't a number. You can't point at it on the number line. So you can't include something that's not even a number. So infinities always get parentheses. Okay. So we've said this section here is decreasing. This section here in green is increasing. And we want to say from here to here. So we're looking at the x-axis again. So this switches to increasing at -1. And it goes up, up, up until we get right here. And this lines up with +1. Okay. These are both going to get parentheses because technically at the top here, we're not increasing. If you think about a mountain, so here's your mountain. It's got a nice snowy cap on the top. If you were walking up a mountain, here you're gonna say, "Oh, I'm walking up. I'm increasing my height." Once you get to the top of the mountain, you're not still going up. You're at the top. You can't go up any higher. I guess you could jump, but we're not gonna. We just hiked up a whole mountain. I don't have energy for that. So once you're on the top, you're not going up anymore. You kind of stand there and observe, right? You're not going down. You're not going up. You're just standing on the top. So the tops are considered constant. So we would say at x equals -1 and x equals 1, we're at a minimum and a maximum. Those tops and bottoms are constant. The same way, if you're standing on a mountain, you're not going up or down. Okay. Now, we still have this decreasing section over here on the right. So we need to include that in our decreasing interval. So what we're going to do is to connect this one over here, just say this spot and this other spot. The first thing we're going to do is put a union sign in the middle. This is the math symbol for the word and. Okay, it's just a big U. There you go. Now we're going to write our other interval for this side after the U. So here is where we switch where we're going. This is at +1. And this thing keeps going down. Oh, there's an arrow there. So it's going to keep doing that forever. Because we're going to the right, these x values are 2, 3, 4, 5. They're getting bigger. We're going to +infinity. Okay. That might have been a little confusing. Go ahead and rewatch it if you need to. All right. We're going to do another example that's maybe a little bit more straightforward, but it looks weird, so we'll talk about it. All right. So the first thing I'm going to do is go figure out where are my increasing and decreasings on the graph, and I'm going to color code them. So increasing, I'll do in red. Decreasing, we'll do in blue, and then constant, we'll do in green. So increasing. If I look at my graph here and I draw my tangent line, oh, that's going up. So we're going up, 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 up until we get to the top. Technically, the very top spot, just that single point, is constant. And then our graph turns around and starts coming back down, 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 down. Okay. This kink right here, and don't make that dirty, kids. This kink technically is nothing. It's not going up or down. There's some calculus stuff here, but we're in pre-calculus. So just take my word for it. We're going to ignore that kink spot. And what I mean by kink is it's going down and then instantly turns into a flat thing. It's got a sharp corner. Sharp corners are bad for math, and we're not going to talk about them. When you take calculus, you'll talk about them. Same thing here. That sharp corner, that's not good for us. All right. Here, this spot's easy. This is constant because it's flat. Then after this kink, our graph is going down until we get to that little valley right there, and then it turns around and starts going back up. All right. So now we just need to turn these 1, 2, 3, 4, 5 sections into intervals. So let's just start over here. There's an arrow, so this is going to start at negative infinity because we're on the left. And this is increasing. So I'm going to come over here to increasing. Start at negative infinity. Infinities always get parentheses because it's forever far away. You can't get there. Now it goes up, 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 up. Here's the part where kids mess up. We don't care how high it is. I just want to know how far over is it. So right here we're at -3. So we're going from negative infinity. I start forever far away and come over until -3. We're going to ignore that point for right now. Decreasing, well, I stopped going up at -3, so I also started going down. So I'm going to start at -3, and then this goes down, down, down until we get right here, and that lines up with -1. Close. All right. Ignore the kink. That's calculus's problem, not ours. This flat spot is constant. This goes from -1 all the way over to 1 to +3. So our constant is from -1 to 3. Now we have another decreasing section. So for decreasing, before we put the next section, remember your union symbol. This starts at 3 and then ends at 4. So we're going to go from +3 to 4, parenthesis. Then this section is increasing. So we're going to put a union because we have a new section we need to attach. We're saying and. It goes from negative infinity to -3. And from 3, oh, we hit an arrow here. This means it keeps going forever to infinity. And it's positive because it's on the right side. So, comma, infinity. All right. Now let's talk about these 2 points here. Technically, you are constant there. So we should do union x equals -3. Union x equals 4. I believe on your homework, if you are not in Mr. Barton's class, like literally enrolled in my class, don't worry about it. What I told you is true. If you are enrolled in my class, then I don't think that your homework cares about those weird points. I just feel bad lying to you because you're going to need it for calculus someday. So if on your homework the only option for constant is this little section right here, the -1 to 3, that's okay. All right, so that's your notes. If you had any questions, maybe go back and watch the video again, see if it makes sense the second time, or hop into the WebEx and ask me for help.